alive. Who you gonna call when you get on the line? Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! 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 If there ain't no curve, there ain't no ball. The globe religion about to fall. We're gonna open your eyes so you can see who you gonna call if you wanna be free. GLOBEBUSTERS! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERS! GLOBEBUSTERS! GLOBEBUSTERS!
And welcome everybody to GLOBEBUSTERS. We accept the reality of the world with which we're presented. It's as simple as that.
All right, hello and welcome to Season 13, Episode 14 of GLOBEBUSTERS. Today we're going to be going over globular evidence, or supposed globular Earth evidence. As always, special shout out to Cami and Bob Nodell for creating the platform, and Cami for continuing the platform. If you'd like to support Cami, you can super chat or become a channel member. All proceeds go to Cami. So we'll read the super chats at the end of the stream. And without further ado here, we'll introduce the panel and we'll get into the presentations. So here we have Karen B, of course. Welcome, Karen.
Thank you. Happy to be here.
Awesome. Zach, welcome, sir.
Hey, Alan. Always a pleasure, man.
Awesome. And then, of course, we have, who's that down there? Is that Shane St. Pierre? Is that Shane over there behind the curve? I can't see him. You're there.
It's actually the angular resolution. Let me pop a little closer.
Oh.
There we go.
Oh, we're just changing the diameter of our optics and we suddenly,
Length.
no way. Interesting. All right, cool. So that's the panel, and we're going to get into some supposed glob Earth evidence and see what we can make of that. Shane, whenever you're ready, sir. Oh, and Kyle is here as well. Let me move Kyle in. My bad. Didn't see you there, Kyle.
So this topic is just so alluring that everyone wanted in, right? Is that what's happening? I just want to be clear.
How's it going today, Kyle?
It's going really good. Good to be here.
Kind of early for you, isn't it?
A little bit, yeah.
I know you're a night owl, so
Yeah,
thank you for taking the time, man.
yeah. Finally, kind of, this is a big topic, and yeah, one I've been really itching to just address with everyone.
Well, before we get into that, I'd like to say something. It's been kind of somber around here today. It's the 2-year anniversary today since we lost Bob. And yeah, a lot of great memories, some rough ones, still. I don't know if I'll ever get to lose those. I think it was kind of a learning thing that, you don't want to forget. Even bad times you learn from, right? There's wisdom to be gained there. So yeah, just think of a memory that you have of Bob, and just dwell on that a little bit today. And remember, he did so. I mean, he lived flat Earth. It was 24/7, and I watched it for years. Like as soon as he would get up, he was, "Hi, good morning," and then, "Hey, did you see this? Did you see that? And it was all day long. It was talking about physics and this and that, and yeah, it was. I feel very blessed to get to have been able to spend so much time with him. You know, he was more than a friend. He was like a brother, a father, a teacher, all wrapped into one big giant teddy bear, you know. But yeah, just let's try to keep it respectful in chat. We'll just get rid of the trolls. We don't even need to comment back to them or anything like that if they decide to pop up. Because that's how Bob always kept it. At least for today. We see him, we'll just get rid of him. So yeah, I just wanted to share that with y'all. It's been a God, it seems like it happened so long ago now, but it's only been 2 years. It's weird. It seems like it happened, you know. Sometimes it seems like it happened only a couple months ago. And then other times it seems like it's been forever. It's losing someone that was at least that big of part of my life. I've learned a lot from it. He's still teaching me, even though he's been gone 2 years. You know, I'm still learning lessons. So thanks, Bob. I appreciate it, man.
We end every episode with peace, and so let's try to remember that throughout the episode to be peaceful, right? Yeah. I know there have been a couple moments where Bob would throw down the hammer and decapitate a few people on accident, or maybe not quite so on accident, but you know, he was passionate. He was really passionate. And but that's, you know, we all have our own flaws here and there, but peace is the thing that we strive for. That's our ambition. So yeah.
Awesome. Yeah, man. Peace be upon Bob. Seems like only yesterday at some points when you look back on it. And I remember just so many times where he was just always encouraging people to learn things, you know, and to keep going, you know, keep going. If you don't understand it, just keep going, you know, keep trying, never give up. It was very encouraging to me.
Yeah, Bob was a great teacher.
Yeah, he would take the time, you know. If it took 4 hours for you to get it, he'd give you 4 hours, you know, until you got it. That was, he cared.
Man was a saint. I got like 20 minutes max in me. If you don't get it by then, like, peace be upon you. All right.
All right, let's get into this.
All right, well, let's get into the globular evidence. Shane, whenever you're ready, sir.
Yeah, I'm ready.
You've got a lot to present here on this subject in particular to knock them down.
Well, I thought I'd be on my own trying to answer this. So having the whole panel here is very reassuring instead. That's a much different way to approach it. I love it. So yeah, we're going to be addressing all of Jeran's supposed evidence that he put forth when he came back from TFE. Also, I'm trying to share. I don't know if you see that.
Do not. Give me 1 second. I do now. We're good.
Beautiful.
The issue was me.
All right, so let's just go through what he put forth word for word, right? So some of his proofs here are the South Celestial Pole. And he says, many have speculated that this spot in the southern sky sweeps across the dome, but I saw it in Punta Arenas. It is stationary like the North and does not move, meaning it's impossible for Australia, Africa, and South America to all see the Southern Celestial Pole in the south. So that's I didn't know that people thought that the Southern Pole sweeps across the dome.
I didn't know anybody thought that either. That's a new one.
Okay. All right. So I'm not alone there.
I used to think that, though. That's like a new thing.
All right. So yeah, like trying to explain what I think he thought he meant is kind of crazy in this one. But I think it may have got confused with like the outside perimeter having the same elevation for the celestial South Pole. If you move the observer in the model, it looks like it's not actually moving. The observer is moving. It's just at the same latitude for everyone, right? It's latitude dependence. But we'll go through that in more detail for sure. That'll be the first one we tackle. And then the other one, I think he specifically means the South Geographic Pole here. So the South Geographic Pole exists. Many have speculated that there is no South Pole because it doesn't work on an FE map. Well, we know what the sky does in the north, and below it lies the North Pole. Using the tilt of the sun, one can see that there is, in fact, a South Pole. And if everyone, no matter where they are in Antarctica, heads south, they will all meet at one spot. It will be directly below the South Celestial Pole, and that is the South Pole.
When was that done?
I mean, as far as I know, he saw it and he saw how it would work there, and he hasn't actually walked. No one's converged. He just said, "Oh, I see how it works now," and that was it.
Okay.
I mean, has anyone seen any evidence of a South Pole?
I still have no evidence
circumnavigation?
of like one person just crossing the South Pole, like going down in South America and popping up in Australia.
Alan and I were looking for satellite orbits that do that specifically, and those are hard to find. So, does anything cross the South Geographic Pole?
By hard to find, you mean completely non-existent until last week. Elon Musk did an extra special circumpolar orbit, and he put some. Dude, go check it on Twitter. I'm serious. They did their first circumpolar with astronauts on board or whatever. It's the most. I mean, there's no orbital flight public or thing trajectory published, or and the video was just like nothing discernible, but they have now asserted the claim after we've been hammering it for months now. So suddenly Elon Musk is like, you know what we need, guys? Send some astronauts circumpolar for the first time ever. All right, bro, we got you.
And all right, his next proof or evidence, he says upside down and backwards moving sun and moon. He says this one's easy enough. There's no way to explain this reversal of direction and flip upside down unless you place us on a sphere, at which point all these things are explained and predicted. So I know Kyle has a video on that one. I was going to queue it up and play it. Certainly when we get into it, I mean, that's going to be an easy one, right? You're my answer for that one. You did a pretty good demonstration of why that's silly. The Tropic of Capricorn direction. I'm a little confused on this one too, to be honest. He says the tropic on a flat Earth map curves right if you're in South America looking west. However, observations tell us that this tropic actually curved left under and around the sphere. All evidence points to this being the case, including known southern sunset angles. My original idea was that he was just misconstruing azimuth of the sun as in a circle and then saying, oh, well, it must go the other way. But I'm open to interpretation on this one.
Right and left are so ambiguous, especially when like you have the mirror effect where my right, you're right. You know, that's like super confusing. So I don't like, even anatomically, when you take a biology class, they teach you specific words to avoid that kind of ambiguity. And so when you were looking at like a body or something like that, there's a different term for left when talking about their left, or that way everyone has no problem with it.
I'm pretty sure it's a perspective-induced phenomenon that we'll inadvertently cover, but I'm just not sure on the wording if we're going to address it correctly because I wasn't aware that was a problem. But so he has the southern stars as a separate one. Remember, the south celestial pole is essentially the southern stars to me. I'm not sure if these are different. It says they've always been one Effie can't answer and still cannot. Are all stars rotating above us as a disk, or does the evidence say that it can't work that way? Well, we'll definitely address that one. Circumpolar stars in the south. It says that stars that circle the South Pole where Octantis would be cannot work on a flat Earth because the southern stars must do a complete circle around the outside of the AE map. So then they can't be circumpolar, but they are. Therefore, they do not go around the outer edge of the Earth. Yeah, I think my only argument there is that I don't think the stars go around the outer edge in a disk above the Earth. I think it's more complicated than that.
So are these the points right here? These are all of them? Everything has to do with the sky.
There's two more, and everything has to do with the sky, yeah.
Okay.
Of course it does.
Yeah, as a matter of fact, they're all southern observations, which brings me to my conclusion, right? I thought that, was he one of the flat earthers who just disavowed any southern observation? Like, had no idea, like didn't argue southern star trails, just pretended they didn't exist. Had no idea the southern sun would ant-arc south of the equator, ignored all of the celestial observations. Like, I know there were flat earthers that did that. Was he one of them?
No, like before he deleted his channel, he had a lot of videos that talked about the stars and different explanations concerning the atmosphere, like a lot of videos. And like he just went and covered it all up by deleting it all and then just pretends like they don't exist anymore.
I don't know. I had been watching Jeran for many years, and I'd never heard him say that if the sun goes circumpolar over the South Pole, that means that Earth is a globe, until just before this trip. In all the years, I don't remember him ever saying that until very recently. If anybody else,
yeah, nor I. No, when he first came out and said it, like,
I was like, "What? What are you saying?"
Yeah.
Well, in fact, his position now, as he described it, was he said, if the South is as described, then Earth cannot be flat, which is a perfectly framed logical fallacy, right? It's a false dilemma. It's black and white. It's all or nothing. It's completely fallacious on like 3 levels to even have that as a position, which is why I was asking. That only would make sense if your previous position was all southern observations are fake, right? And then he makes one southern observation and going, oh, well, I guess they're not fake. That's the only thing I can think of. Trying to be, good about it or whatever.
Yeah. Man, where's Irio today? Because like he's from Argentina. That's South America. There are a lot of different flat earthers out in South America who are very much aware of the stars in the sky and the way that the sun moves and stuff, right? And so if this was a huge problem, we wouldn't have this many flat earthers from South America and Australia and all these other places. Like, they get it. It's not a problem for them. Okay. And that's for a reason. It's not, yeah.
Yeah, they've been studying the sky for thousands of years. And you go back to, even biblical writings talks about, God will abandon the Israelites when you can measure the earth and the sky and the heavens. When you figure that out, that's when God's gonna like almost a jest. Like, it's not gonna happen. You're not gonna be able to figure this out. The heavens declare the glory of God, and the firmament showeth his handiwork. He can do things that we cannot comprehend. I think that's what that means. That whole saying is, the firmament, whatever it's doing up there, that's separated the waters from the waters, is doing some really amazing things that we just can't comprehend how it all works.
Well, his other 2 proofs are also sky and sun related, right? Sunset and sunrise times and angles are shown to match reality for every location only if Earth is a sphere. If we use any other shape, it becomes impossible. He says, so the globe predicts every sunrise and sunset for any location on Earth, and flat Earth cannot predict one. I'm going to take care of that one. That's going to be rather easily addressed. And his last one is the second apparent sun needed. He says, flat Earth steals known observations for no rhyme or reason and places the second apparent sun exactly where the globe predicts it will be, and then say we predicted it. There's definitely some truth to that statement. He says, oh, I might be missing one, but these things will not be answered, in my opinion, and are reason enough to at least consider we have been very wrong. If you have the answer, reach out and I'll take it off. So I wonder if he's going to reach out and take all these off after today. Well, the first one I wanted to address was the stars, right? Let's do, he named it first, but it's really like number 1 and 3. So the South Celestial Pole and Southern Stars. I have a video for that. It's about 9 minutes specifically addressing it. Let's see here. Change sharing. There we go. Cool. And we have volume, I think. I took the music out specifically for Alan.
My man. Is there audio playing right now, bro?
Yep. Okay. All right. So I just didn't share that right. Share with volume, maybe. Also share. It's on. Oh, to share volume, share screen instead. Okay. Yeah. No, I didn't do it. All right.
All right, let's go through the basics real quick.
Right,
so
ready.
Shane can explain how the stars work. Right, so this is you. This is how you perceive the sky, a hemisphere around you. Nothing groundbreaking here. Everyone agrees on both models, as far as I can tell. On the globe Earth, this is exactly the same. It's the basis for the creation of the globe model in the first place. The movement that you see happening, you would think is because of curvature and no other reason. Even though every day other tall buildings, mountains, people, street lamps, everything in the world recede into the horizon proportionate with distance as a facet of perspective, we're just saying the stars are doing the exact same thing. The globe position, if you didn't know, is that actually the stars are doing the same thing, but for a completely different reason than everything else in the known universe, and that's called curvature. We have a completely solid, math-based, logically cohesive alternative. Our radius, of course, being a facet of the limits of perspective. Absolutely sound, mapped out. Makes total sense. You can derive the radius right back from the optics of the human eye. You can also play with proportionalities on the radius criterion to do the same. So, how do you see celestial objects? Like this. They appear in the hemisphere around you and then appear to move either of their own accord, 15 degrees per hour, or with you as you go across the axis here. Move 1 degree in the direction of movement as you move 69.07 statute miles in proportion with your direction of movement. That's all we're saying. And here's just an orthographic view of stellarium showing you the same thing, except my star isn't moving. This is just a 15 degree per hour rotation sped up over a person with a celestial sphere of globe proportions around the observer on a flat plane. Let's just do a quick walkthrough about how the stars and the celestial poles work on flat plane. So to start, let's just assume that you see in globular dimensions, meaning you see in a hemisphere around you on a flat plane up to the dimensions prescribed by the globe. So in a sphere or half sphere of radius 3959. If you were to take a circumference of the circle, the limiter view would be about 24,901 statute miles in a circle. Apply this to the celestial heavens and we get a latitude-dependent pole around which things appear to rotate in the north. Circumpolar stars in the north. Here we have a 45-degree tilt. Someone in the northern latitude looking at the stars. This is what they see. Polaris. Right about at an angle, not directly at the zenith, not directly at the equator. So going to the equator, you start to see both celestial poles pop up. Now, this is because the optical convergence known as the south pole starts to pop up. If you look back over here, only right about here is when you get far enough away from the center with your hemispherical limit of view to, first of all, lose the original only center of rotation. There is only one rotation of stars. Interferometry, every measurement ever taken of motion has only registered one source center of motion. All the interferometers have to be aligned to this source of rotation or motion. They cannot be aligned to any other. It is only one, singular. So when you get far enough away from this singular source of rotation, your limit of vision, judging by the example of corpuscular, anti-corpuscular rays, which would appear to bend what is flat light or parallel light above you, it would appear to bend that parallel light into a dome around you, and that your vision does the same thing just to the nighttime sky. It only makes sense that you'd experience the same thing at night as you do during the day. So during the day, if your vision is bending these parallel sun rays above you and they're arcing them into convergence points behind you that they're not really doing, your perspective is doing that, then that's all that we're saying is happening at night. Your perspective is taking these long star trails that are emanating from a singular source and spreading outward, and it's warping it into a counter convergence point produced by optics only when you get to the equator, only when you get far enough away from this rotation, okay? And when you go further south of the equator, you get the optical convergence point known as the South Pole popping up because it's latitude dependent. And that would be the point around things which appear to rotate going forward. Right? Now to take it out, to make it a little bit bigger, back it up. Again, if you're under the North Pole of the zenith, this is what it would look like. Everything spinning around you like a perfect hemispherical dome. It should be said, this is not to scale. And my model of the dome is much bigger just to show that scale, but for all intents and purposes, it represents the globular dimension. So it represents a dome of radius 3959. It's not in scale in proportion to the map around it. We'll go over that later, but just so everyone knows. Notice the similarity to a globe. Right? If you're standing right underneath it, this is what you'd appear to see. Everything rotating around. Now, if you move your observer just a little bit, say halfway between North Pole and the equator, about 45 degrees, you get the apparent rotation convergence point appear to rotate. It moves about here. Go back to the equator from this side, and we get to see the same thing. Equatorial star trails, where both poles appear to be visible, but neither one really is. They just be equatorial. Both appear to be polarized. Now you go a little bit southward. You're far enough away again from the central rotation. You're far enough away from this where you can no longer see it. That's why it appears to dip below your horizon. 6,218 miles is the distance to which you can see that above the horizon. When you pass that distance, you can no longer see it. It's appeared to set. It's over here. And now you have the counter convergence point known as the South Pole, the optic convergence, appearing to pop up and is now latitude dependent inversely and is now the point around which stars appear to rotate in the south. Again, latitude dependent. So it's maintaining the same degree of latitude, the same elevation depending on your latitude in the south. The same relationship that Polaris has with elevation angle, that is to say synonymous with, the south optical pole convergence remains the same relationship in the south. Again, maintaining directionality here, of course, has to be maintained in a circle around the central cylindrical axis for this map. That's why the compass is moving forever. It always is maintaining the relationship to the center. We're going to overlay our stellarium orthographic view to see the exact same thing with a little bit more graphics. See? Stellarium uses the exact same model and the exact same method to portray the star. In fact, it uses a stitched together grouping of azimuthal or alt-az horizon-based coordinates that they then modeled to create the celestial sphere. Flat plane angles stitched together to create a bigger sphere that, when unraveled, would mimic a point-for-point correlation of the celestial sphere to geographic long latitude. That's all it is, guys.
Awesome.
The reason I can
Right, and I should have said this is just my explanation, right? My opinion for the stars, to try to offer a dynamic explanation for all the things in the sky is kind of crazy, but this is, me taking a stab at it.
Well,
And,
you got to
you
insert curve somewhere.
Right. Well, yeah. Well, that's what this is, right? It's like you can either have a flat plane with a curved or a curved celestial, or you can make the celestial sphere with a radius of infinite tangents to your observer-centric plane. Anyway, it's all just playing games with the same thing.
view of stellarium onto the flat Earth dome models because they are doing the same exact transform. They are taking a personal alt-az coordinate system and transforming it to a celestial equator-based right ascension declination. So the celestial sphere effectively is just a conglomeration of alt-az observations of the sky from all over Earth that they stitch together into a ball contingent upon the correlative relationship of longitude and latitude to right ascension declination. So because for every star, there's a ground position and a time, because of that one-for-one correlation, they have mapped these two spheres one-for-one to each other. But this is just...
Dude, it sounds bad because I took the music out, Alan. This is actually me reading it. It's not AI. It sounds AI because I use the IDRMU music, dude. That's why you're laughing.
Oh my God.
Taking a geodesic or geographic coordinate system or the celestial sphere and converting it to your local alt-az grid. That is all that is happening here. So when people try to misunderstand or misuse, it's just ignorance. Same code process. Not the exact same code.
Yeah, each one of these is doing a coordinate transform from local alt-az to celestial, right, based off the celestial equator. So they just do coordinate transforms to get into local alt-az. Same thing's happening over here, and it transforms back and forth as you move. That's literally the foundation between both. That's why I'm comparing it here.
In different languages, but the same process of coordinate transform and translation making this run. That's all it is. Like geodesic to alt-az, boom. And then as you travel, the same translation, although applied differently, right?
But so that's where I think people get confused. If Jeran said the South Pole moves, like, no, it doesn't. It's just at the same latitude visible for everyone. That's the only thing I can try to think to justify that presupposition, which the South Pole moves. I've never heard that.
Latitude dependency. So the first principle was the rotation and counter-rotation explained by perspective and relative motion. We had one actual center of rotation. We had apparent motion of that rotation changing depending on where and which direction you looked, where you were on the Earth and which direction you were looking in. The motion never changed, but your perspective induced the motion to appear to move counter, right? Everyone remembers that. Just going back to P-Brain's video about rotation and counter-rotation, and perspective being the root cause. Find it helpful to go through each phenomenon and its effect, and then to make sure we know what is causing each effect so that we don't inadvertently loop other causes to other effects. So we have the counterclockwise rotation in the north appearing to rotate clockwise in the south as its counter. Once you move in the south and look to the south, you see the counter rotation. The toilet paper tube rotating in one direction but appearing to rotate in either depending on which side you look is the best example of this uniform motion that we can ever use. Perspective alone will show you this rotation moving both ways if you look in one direction or in the other. That's the simplest way to put it, and it's the best explanation for the counter rotation that we see in the south.
You're right.
We have
My
the
left.
crepuscular rays of the sun convert.
Right? This is the best example I've ever seen. This is straight out of P-Brain's video, by the way, which I thought was excellent. Anti-crepuscular and crepuscular rays, right? That's his whole video. And literally the best explanation for perspective-induced rotation and counter-rotation. Right? If you under your nose and you look left and you look right, you see something different, you know it's rotating in one direction.
Converging behind you on the opposing horizon to show you that you see in a sphere that your vision will wrap light around you in this fashion. So that means that your perspective over the great distance will put things that aren't converging in a convergence point, like the end of the rays of the sun. They're not actually converging around only you. They're going out in perpetuity in both models, right? But in your model, perspective puts those rays around you, even though apparently to you they're parallel. So just a quick thought on motion and perspective. We only have one source of motion, but our perspective makes it look like more. If we have motion like this, and you're in the north, they see that stars are rotating one way. Everything goes together synchronously. If you go south, however, and look from the opposing viewpoint, if you turn around and look the other way, then the same motion converse, right? It looks the opposite. It looks to rotate the other way. See how that works? It's in the same rotation, same motion, depending on where you're looking from, will make it move one way or the other. Simple explanation. I do want to make sure we keep the observed effect and the mechanism separate. For each effect, we'll keep the mechanism. If it's more than one, we'll write it, but we'll have a specified mechanism for each observed effect that we deal with. So second one would be convergence and counter-convergence. If you're looking from the opposing horizon, when the light beams appear to converge on it, we'll call that the convergence point. And then when they extend past your head over behind you and converge on the opposing horizon, that's the counter-convergence point, right? The place where they're not really converging there, but if you didn't know that, you would expect to see a sun right where the beams converge. The mechanism that we had for that is the optical limit of your visual space and sufficient distance. Understanding that you can see 59 miles into the sky in any direction, creating a little sphere of your celestial horizon that moves with you wherever you are, governing the limit of your visual space. And you'll notice that at the edges of the space that you can see, your vision will put it into a sphere, meaning that what you see will appear to converge.
I like using railroad tracks for that because they appear to converge, right? They don't actually converge. Your vision is doing that. It's an aspect of perspective. Same thing happens to sun rays, which are seemingly parallel, to be wrapped into anti-crepuscular rays around you, right? And this was, I think, the basis for when Witze was adopting it as the azimuthal grid of vision, literally just describing easily how you make celestial observations from a flat baseline. You have your elevation angle from your horizon, right? That's the altitude, super easy. And then around you from north, you have your azimuth, which is in 360 degrees, starting at true north in the center, all the way around to get this elevation, right? And that's the whole concept. And then, of course, I like to do this model because the stereographic projection of stellarium and the local alt-az grid in this model are like symmetrically, they're exactly the same, right? And each one is created by making multiple observations of the celestial heaven and then wrapping those observations to form the bigger celestial sphere. In fact, the book Geographia by, I forget who, is the biggest, the first book on geography ever put forth. Petals, yeah, taller than me, said that you have to adopt the two-sphere model, so the terrestrial and celestial sphere, and that's how he put them together. And when I was going over that, I started that, I think, right here. When you reference the terrestrial and celestial spheres, you have to accept that both of them are conceptual models that they stitch together by creating ground positions, where for every point on the Earth, there's a point on the conceptual celestial sphere that matches it for a specific time, right here. For every point on the Earth, there's a specific point in the sky that matches it, and conversely, every point in the sky uniquely corresponds to a point in the Earth, the point on the Earth at a certain time. And that's the relationship between right ascension, declination, and latitude, longitude. So those two conceptual spheres are just amalgamified together. And if you don't accept that, then you can't understand the process in Ptolemy's words. That's how his preface to the book starts. If you don't accept this model, you won't be able to read my book. All right, so that's Southern Stars, Star Trails. What do you guys think?
I like how you brought wireframe at different positions. And it's really important for people to remember that this is just a wireframe. You can have those stars being really irregular, having a star being really high and really low, or in all kinds of different ways. It's just kind of, they're there, and it's just, they got to move around somehow. And that's just kind of how wireframes work.
Well,
Yeah,
they
it's
move in
latitude
an
density.
equidistant web anyway, like just optically. So like you would never even know if one's higher than the other anyway.
Yeah. So this doesn't show a firmament, any kind of solid structure that's bending the light. This is just saying the lights are up there, they move around, and this is the observed thing that we see. And so you're showing the personal dome of vision right here. That's what we see, where the stars appear to be, not where they actually are. And then there's up in the sky there, somewhere up there, and there's different ways of orienting them. But this is just a wireframe that illustrates it in one way.
Well, yeah,
You can move the stars around in different places, and they can behave in different ways. But the light has to bend in certain ways in order for this kind of stuff to happen.
Well, I specifically only deal with the apparent position, right? That's why I'm only focusing on this part, because that's all that we correct for. That's all celestial navigation uses for. That's all we use for anything in practicality. So, like anything about the orthographic so-called true position is kind of ignored.
Later we'll go at the end. We'll go over the orthographic true position with a little Cell Theo update.
I just don't want to exclude any firmament believers out there, because there's a lot of us here who are all about the firmament of heaven.
This has nothing to do with firmament or seeing anything off of a firmament. This is just how you perceive things optically from what you can see.
Right, like the I was gonna say the dynamic cause is just if you don't see forever, that imposes a limit. If you have the same limit in every direction, that creates a hemisphere. That's the only geometric cause going on here.
Yeah, it's not explaining anything about the mechanics of the sky or how it's doing anything that it does.
No dynamic
speculation.
Yeah, no dynamic explanation included here.
Wait a minute, you don't have a ratio of how much the Earth weighs that corresponds to the distance to the sun or anything like that?
Well, we can use one, right? We can try to think of one.
Yeah, it's been many distances over the centuries, right?
Mm-hmm.
I saw 3 million, 12 million, I think 33 million was in there at one time. Then it went up to like 120 something million. And then
I don't think we should rule out 33 million, guys. We should keep that in our back pockets just in case.
Interestingly enough, Zach, that's just manipulating the angular size formula, right? When they take the only known constant, which is the angular size disk of the solar disk, like how big it appears to be, 0.53 degrees. And then they use the formula like equals 2 times the arctan of d over 2d. And they just change the diameter and the distance until they get what they want. So if you backtrack that and you can just change out Copernicus, Tycho Brahe, Kepler, Newton, Martin, Encke, Meyer, they all just changed different diameters and different lengths, and they kept the same diameter, the same solar disk size, and those would be the options that you get to output. Like, it's 3 million miles away, but 322,000 miles across, or Meyer, where there's 104 million miles away, but it's 11 million miles across. It's just the variance, right? The covariance scaling of the same proportionality, which, funnily enough, guys, I learned from Jeran. So
if someone asks you how far away the sun is, your response should be, how big do you want it to be?
Right, exactly.
Yeah.
All right, so the next one was the sunrise and sun arc angles, I think. And then he does sunrise time predictions. We're going to do that separately. But this one's just on sun angles and how the sun appears to us. I think it has volume, though. Do you have it muted?
Oh, yeah, I do. 1 second. Let me turn it back on.
Yeah, there's this big yellow message that says you have it muted.
Yeah, it echoes when we talk. But we're good.
Right.
A little bit about the sun angles, or more accurately, the sun's arc. Right, the path the sun appears to take in the sky over any observer. If we start at the equator, it's the only time you'll see this equidistant line indicating complete symmetry, right? So there's the sun right over here. It's rising to this observer due east, right? And it's rising, it's going to its zenith, and it's approaching, and it's going to set. Now, of course, the real sun is all the way over here, going around its circuit where the GP carries it between the tropics, and where it's observed for this observer is who's exactly on the equator is the only time you'll get this perfectly symmetrical line, right in the middle. Anywhere else in the world you observe the sun from will have an angled arc, right? If we go a little bit north, say about 45, and we look at the same thing, we see the sun now does this crescent, right? If we look at it from the south, it would do this. It does this crescent shape. Hey, here it is. Again, this is the sun, this is the moon, sun rising and setting. And now it's no longer making a perfect symmetrical line. It's making this arc. This is the path of the sun that you would expect on flat Earth. The flat Earth model expects the sun to be moving in inclined arcs because that's how it's observed all the time. In fact, from that observation, they have coupled together the globe model, right? Based on flat Earth elevation angles or a flat plane and an observed celestial body making an arc as it rises and sets, and also are decreasing arcs as it makes its journey from tropic to tropic. And put that all together, it would appear at the north and at the south, and this is how you get the globe model. You get the inclination of the sun's arc manufactured to create this theoretical ball, without which you would just move this celestial arc back and forth as you moved in latitude, right? This is a good representation of what we're talking about. In January, it's making this low arc, right? In March, it's this higher arc, and in June, it's this super high mark, right? In midsummer, almost. This is where this person is, right? And you can see it's almost at its zenith. That's the only thing that creates the southward crescent for the rising and setting of the sun south of the equator. It's the inverse that you would see in the north, right? If you took this and moved it around and just inverted it, that's what you would see. This is what you would see as a northern observer looking south towards the sun's path. And again, another representation is it's making its celestial arc, and its arc is season dependent. Again, this is where they created the 23.4 degree tilt of the whole world, because they were assuming first parallel light rays, and also that this was symmetrical. So therefore, the whole world must be tilted at this axis, right? It's all contrived based on this simple observation. The sun doing this arc, as we saw before, the sun doing an arc. You look at it from inside, it would be doing this, right? Rising and setting, just like this. So when we take it to explain a southern observation of a southward facing sunset, it makes perfect sense. We move our observer, say south of the equator, we're in South America. We have it rising and setting south of east, right? So if we look at our bearings and our compass, this crescent, which again is matching the crescent we just looked at, the only way it can work is it's rising south of east, so south of this eastward line, right? And it's setting south of west. So as it goes across, its zenith is up top again, and now it's curving back down to set. And again, it looks like this as it sets into the apparent opposing direction. That's what the sun would look like. That's what we would expect on a flat Earth with a limit of vision, right? The mechanism that causes this cutoff of all you can see is the physical limit of your vision, right? If you don't see forever, then you would have a limit to your vision and same amount in all directions, then it would create this hemispherical dome above you. That's just the natural geometries that we're talking about here. It would create this. If you have a limit of vision, this is how it would look.
Right. So this is why I said I think southern observations were ignored, because if you took just what starts to happen south of the equator as it mirrors north of the equator, the ultimate conclusion would be a 24-hour sun, right? Because you can see it starts to anti-arc more and more the more south you go, just like it does in the north. And because we have 24-hour sun in the north, the natural evolution to that thought would be, well, we must have a 24-hour sun in the south. But most of us ignored that, right? But, anything south of the equator would have leaned in that direction, observation-wise.
I did a video back in 2016, where I think it was 2016, with a hemispherical lens and a bunch of circles on a piece of paper. Set the hemispherical lens down, and at the center of the hemispherical lens, you can make the North Pole. And no matter which direction you move that around that piece of paper, the outside edge directly opposite of the North Pole, it created another pole on the other side of that hemispherical lens. So like half of it's already there, the possibilities. Now, how it all actually, to get it to actually work, yeah, there's something there that hasn't quite clicked in yet. I think Cami might be on. She's been talking about this since 2015, 2016. The southern star rotations and how the sun and the stars could go around, magnetic poles. If you had magnetic things happening in the sky, they can mess with optics. So we've been thinking about this for a very long time. It's not like this was new to any of us.
Right. And again, I'm not trying to explain the dynamic cause of what's up here, but if we were to speculate, right, wildly just between the boys or whatever, we can come up with following, the toroidal flux lines of the actual moving magnetic field of Earth. It says that's in motion, then the sun's path would be able to follow that. Or is it caused by that? Or is it following in the trail of that, right? So, I mean, I don't know. Could be. But what we're describing here is empirically what we observe. So, like, the common misconception here is that, oh, you see how the sun does that? That's a globe observation. It's like, well, no, that's an observation that you built the globe with. This observation is independent of each model, right? You could take the real world observation and apply it to your model and come up with your own dynamic cause for why you think that's happening, right? That's how observations work. You can't just say the globe owns all observations of the sky.
Ooh.
And that's what you would have to do to say that all observed sun angles and arcs and antarcs belong to the globe.
You didn't get that memo? If an object in the sky makes an arc, it does so because the Earth's a globe.
Right? I mean, that's what it comes down to.
Well, and then I don't know if we're going to address it, but are we going to talk about stellar aberration at some time in this live stream?
I mean, that wasn't one of his proofs, but if you want to
He taught me about stellar aberration on his, before he erased a bunch of videos back.
That's my favorite subject.
2016. He taught me about James Bradley. He showed me where on the NASA website to go. And then I made a video about 6 months later because I went to go show it to somebody, and the whole article was gone. I made the video still up on my channel. Where is the James Bradley article here in NASA? Because that's where it explained, only certain groups of stars might move backwards 4 times as much as they normally move forward. It's not just one star doing it. There'll be like groups of stars that move backwards. And instead of marking it as going -4, the average that they move forward each year, they just mark it as a 0, like it didn't move at all. That was taught to me by Jeran.
It reminds me of negative parallax. When 47% of your data doesn't agree with you, what do? Throw that shit out. Don't worry about it.
Yeah, that's actually what he was talking about. He didn't mean aberration.
Parallax. Okay. Negative parallax is funny, dude. That's the craziest thing I've ever heard. So when you're going to use it from relative motion, if more than half of it is on your side, you're good. Okay, what about 47%? You're still good. Just throw the rest of it out. But anyway, so that was the sun arc, and I have another video for predicting sunsets. If you guys want to, or no one has any other questions on the sun arc, predicting the sun arc in the sky.
No, I mean predicting the sun. It's a movie that you watched last year. And this year, when you watch it, the movie's going to be the exact same. It's going to do the exact same thing you did last year.
Ooh, actually, let's
not predicting anything really. You're just saying, hey,
That's
the
what
sun
I
was
don't
here
get.
last year.
Why do they think the globe predicts anything? Like everybody just observed the sky and then wrote it down, and the sky kept doing the same thing over and over and over, and that's how we know
what it's going to do. Yeah,
what it's going to do, because it just keeps doing the same thing.
Within like 0.2 of a degree, it might be off from last year to this year or something like that. But it's always like within that 0.2. I checked it for like up to 2040 something.
Yeah, and then there's something like it takes like 600 years for the sun to go exactly back to the same spot. Like it does it's off by just little tiny increments over the time, still doing its same basic pattern, but it takes like 600 years to get exactly back to spot number 1 where if you started to keep track.
Mm-hmm. It's wild how long we've been looking at it.
Mm-hmm.
And still we look at it like, I don't know what you are.
Right.
As far as predicting where someone's going to observe that, right? That's been done. This is Stephen Alonso's thing from the TFE, regardless of his other ventures or whatever. I think this prediction is mathematically sound. What he did was pretty much use basic geocentric observations. He used the graticule. He used a little bit of law of cosines and spherical trig, but that's working with the coordinate system in my mind.
Law of cosine.
Yep.
Does that mean globe?
So absolutely not, right? But
No?
so let's see. What it comes down to is this right here is our angle formula and his prediction to get the correct azimuth. And this right here is observer latitude, right? So we're using the graticule. And this right here is solar declination, which is, taken off of the celestial equator, and we're getting the cosine of that. That's the basis of the prediction. And he does predict the accurate time the sun will rise in the azimuth, right? Because obviously the sunset and sunrise are at 0 elevation. So the only correlative part would be the azimuth. And to get the correct azimuth, all you need is our angle, observer latitude, solar declination, right? So planar trig, time zone conversions, and hour angle transformations is all you need. I went through this. There's no radius, there's no circumference, there's no globe metrics whatsoever. And then he comes out with the correct prediction for the sunset azimuth, right? Which is, I think, 228 degrees, 229 degrees southwest. So talk about not predicting no one can ever predict the sunrise. There you go. Perfectly predicted out with some math. No globular components used. But
there's no globularity in there?
Nope, I checked. I double checked it. I went through it looking for, 39, 59, 20, 24,901.
There's no globular unit or whatever.
There is like I said, spherical coordinates, right? So solar declination is going to invoke that, as is the graticule and any long lat reference. But I think those are different fights that I like to particularly take on.
But the actual size that we're given never shows up in the calculations.
No. Nope.
Which is what they say causes sunrise and sunset.
Right.
But it's just an illusion every single day, refracting like 4 sun widths. They say it's only 2 degrees, but that's 4 suns. When you're looking through at a sun through a camera, 4 suns would be like way off, it would take up way longer than your screen. So 4 suns is a lot when you're observing the sun, especially through a solar filter. That's huge. And to tell me that happens every day perfectly like clockwork, it just refracts perfectly to make this work.
You're not a fan of perfect refraction?
No, I have issues with that.
When it comes to tilting left and tilting right, I think he's talking about the seasons and how the sun kind of tilts northward and tilts southward. But the thing to remember is that just like the sun kind of comes up over our heads and then refraction ends up causing it to come downward, the same thing happens with the North Star and the southern stars, right? And so the only difference is our position, because the stars aren't moving north to south or anything like that. But if they did, they would behave just like the sun. But instead of the sun moving north to south, it's us. And so the further north we go, the more the stars are going to be like directly over our head. And then all of a sudden, as we move southward, all of a sudden now those stars are going to start tilting downward. And that's the big thing. So this isn't just a one directional thing. We've got like this whole hemisphere of the stars here, right? The whole thing. It's not just a east to south tilt.
The sky behaves the same everywhere. That's how they got the globe, right?
Yeah. But I'm at my time limit. I got to get going. But yeah, thanks for having me for this little bit.
Anytime, Kyle.
Well, thanks for dropping by, Kyle.
All right, take care, Kyle.
Let's see ya.
See you Thursday, man.
Okay, see you Thursday.
Kyle Adams, everyone. Had
Later, Kyle.
a growing channel at one time. Like, it was really starting to grow, and they erased everything. They canceled it, so he had to start all over again. And he's building it back up. But yeah, if you're not subscribed to Kyle, it's just his name. Kyle space and then ADAMS. Kyle Adams. Really nice guy. Good, clean stuff. I mean, you can show anything he makes to your children. Guaranteed. Unless he explicitly says it, which I don't think I've ever seen Kyle make anything that was
No.
just made for adults. No.
Mm-mm.
You guys
Great
haven't seen
channel.
his Flat Earth Raw and Cut series? Dude, it's wild. I did not expect that from Kyle.
That'd be hilarious if on the side Kyle was making videos like Bob Saget. He remembers that.
That's a name I haven't heard in a while.
So you got that
Alright.
video ready?
Yep, this is sunset times and predictions, flat Earth versus globe. It's muted still. Definitely just me talking. So
No, it's not muted.
it says this the host. Oh, unmuted your screen share. Look at me, dude. See, the problem is me this time.
The other thing I wanted to address was the claim that the sun angle predictions cannot be done on flat Earth. But as Decimal Z, for one, and other legends and G's pointed out, and as anyone who investigates it will find out, the sun azimuth was a problem for flat Earth, right? If you assume it's right over the GP at all times with no other considerations and that you see forever, then yeah, if you imagine the Earth being flat, that would pose a problem. It always has been. The way that we solve that problem is with a spherical limit of vision. It gives us the correct azimuths for observation and prediction of the sunrise and sunset that go along with the correct elevation angles that we already had. So together it gives us the correct azimuth and elevation of sunrises and sunsets for everyone across the Earth. Jeran's claimed position was if the south is as reported, then Earth is a ball, or if the south is as described, then the Earth cannot be flat. This is logically fallacious, and in fact is a textbook example of a black and white fallacy, or also known as an all or nothing fallacy. It's an absurd way to surrender all of the irrefutable evidence of the absence of Earth curve or Earth motion in any terrestrial experiment known to man. Which is a part of why it's fallacious to dismiss this giant body of evidence that exists to support the lack of terrestrial curvature based on the purported dimensions of the globular theory. Now, logically fallacious claims and positions aside, we can address the claim as is. Sunrise and sunset times vary according to the season and the arc of the sun, or the celestial arc. We know there is a celestial arc in the sky, so to speak, that describes the latitude dependency that we see both at night and during the day. The only place without this arc is the place that references the sun's zenith in its definition, right? Namely the equator. The sun passes directly over this line, this imaginary line drawn underneath the sun's zenith during equinox, and most other celestial alignments are actually based off of this. Right, it's the axis from which coordinate systems are spawned. Entire coordinate systems exist that use this axis as many different things, including part of the fundamental plane separates the Earth into two hemispheres, or the coordinate system celestially into northern and southern hemispheres. And from this point, known as the equator, right, if the sun is directly above you at equinox, any deviation north or south of this line induces either an arc or an antarc in the celestial arc. That is to say, the sun's path will either start to arc or antarc in either direction, depending on if you go north or south. Right? This is true for either model. And again, with a spherical limit of view, and you don't see forever, then this would directly explain what we see. It would directly explain these observations. Again, the dynamic cause of this is the spherical limit of vision. The only thing we need for these observations to fit our model is that our vision has a spherical limit. This accounts for the swinging azimuth of the sun rising north of east and setting south of west, depending on the season. It does not explain the 24-hour sun as observed in Antarctica as a dynamic cause. It merely accounts for the azimuth. The model that Jeran uses to model the sun observations is remarkably similar to the model I use, wouldn't you say? In fact, since the projection underneath is exactly the same, you might argue that it's merely two different representations of the same exact data. This is in fact exactly what it is. It is often erroneously argued that these observations of the sun, namely the azimuth and elevation of the sun, are actually globe observations, somehow implying that all celestial observations or all observations of the sun are globe observations. This is obviously absurd. It needs to be clearly understood that although the globe model was built from and to support these observations, the empirical measurements themselves are model independent. You can use these observations in a number of different models, and they would each need their own dynamic explanation. The empirical observations themselves prove neither model, and I cannot stress this enough, as there has been significant confusion in the community over this point. So, can the flat Earth predict the sunrise and sunset by azimuth and elevation angle? Of course, for any observer, any place, at any time of the year, just like the globe, using timeanddate.com and empirical observational data only.
I see now that I was supposed to do the PDF after this video, but that's cool. It's close enough. We went through it one and then the other.
That was good.
Yeah, Jeran always uses this funny program, which is literally SunCalc, and he uses you can't model it for an observer on the spherical Earth. You have to use a local azimuthal grid over any observer, which is like, oh, well, if you're going to do that, you can do it everywhere. And it turns out it's what you have to do, even on the globe.
You can do that on adl.place/Shane's model, I think.
All right, so that's sun arc, sun angles, south celestial pole, southern stars. I got one more for south geographic pole, unless you guys got questions or we got comments.
No, I don't. I'm looking in the chat, see if anybody has any. No, these have all been really easy to. Now, again, I've been looking at this for years, but yeah, this is really easy to absorb. I like stuff like this.
Nice, yeah, very visual, heavy explanations.
Mm-hmm. Yeah, the visuals always help. Always help.
All right, then on to the big one. So this one encompasses the south geographic pole and converging meridians as a proof or evidence of the globe.
All right. So addressing Jeran's supposed globe proofs, number 3,
6 or 8
south
or whatever.
geographic pole. So south geographic pole, not to be confused with the south celestial pole. South geographic pole is really defined as the southernmost point on the graticule, located at 90 degrees south latitude. It's got longitude undefined because all lines of longitude converge at this single spot, right? So its definition ties to the very meridians that converge to create it. So we should talk about these meridians, also known as lines of longitude. Are lines of longitude real on the Earth, or are they calculated from the sky? Well, they're also known as meridians. They are, by definition, imaginary lines that run from the North Pole to the South Pole and are used to measure usually a location's position east or west of the prime meridian, right, in 0 degrees longitude. It's told usually in degrees, but its analog is right ascension, which is told in time, which is why if you need to convert between the two, you just do the hour angle transformation and convert 15 degrees per hour into that. So longitude lines or meridians do not physically exist on Earth, but are part of the geographic coordinate system created by us to map and navigate on the Earth. So they are imaginary lines. They do not physically exist. They are conceptual tools for mapping and navigation. So now, I can see how Jeran would think that the south geographic pole would logically sit at the convergence of the longitude lines under the south celestial pole. Right, he went down there to the edge, stared up at that convergence point in the sky known as the south celestial pole, and said, well, the geographic pole must be right underneath it. I can almost see it. It's right over there. This is, however, how it works in the north, right? But symmetry, and specifically physical Earth symmetry, has forever been the globe's downfall, right? Spherical symmetry is where the globe dies. The globe needs symmetry to survive. So to understand and define the south geographic pole on flat Earth, we would need something to display it on, right? First and foremost. So then, is there a flat Earth map on which to demonstrate this? Surprisingly, I have to tell you this. No, there is no flat Earth map. right? There is a useful flattened out projection of the geographic coordinate system that shows the graticule flattened out. And this is what we commonly use to display flat Earth, right? It's also the same coordinate system from which the orthographic globe is produced. So is this the real flat Earth? Well, is Australia that size in real life? Or is it a model of or conception of the world as flat with proximity in mind? If one forgets that this projection has the same geographical data as the globe, that is to say, it's based on the same coordinate system to different projection of the same coordinate system, I can see how one would be confused. I know that Jeran's position was something like, if the South is real, then Earth cannot be flat. Right? So instead of applying real-world observations to the conceptual model for southern celestial observations, he was already in an all-or-nothing logical fallacy. When he observed the 24-hour sun, he went to the nothing side, right? All or nothing, he went nothing. So, i.e., the Earth is not flat and must be a globe. So, and on flat Earth, right, the south geographic pole is still defined in that coordinate system at 90 degrees. So it's defined within lines of longitude that don't exist on Earth, that converge at a theoretical point in a spherical coordinate system called the south geographic pole and is defined at 90 degrees. Of course, on the azimuthal equidistant projection, this point is literally the outer ring of latitude. This is why globers try to get a gotcha with where's the South Pole on flat Earth, because if you think you live on a map, then this point is literally the entire outer ring, right? Does this mean that the South Pole is actually all of the outer ring in sort of a magnetic rebounding field? Well, the magnetic pole is something else entirely. But for the geographic pole, no, that is certainly not the case. We would argue that there is a ceremonial pole somewhere, and it could easily be anywhere along the outer ring. So, of course, it's just represented as that in this projection. Remember, the azimuthal equidistant, or the Gleason's map, or the AE model for short, is a North Pole-centered azimuthal equidistant projection. If we change the center point a degree or 5 in either direction, the South Pole, which only exists in this coordinate system, becomes visible because it moves from that outer ring of 90 degrees. Now, this is still an azimuthal equidistant projection, still in the same graticule. We haven't changed any aspect of the projection. We've simply moved the projection point. All other aspects have remained the same. So is this still flat Earth? Or is this the conceptual model being shifted to show the point that was otherwise obscured? In fact, you could change the central projection point a number of different ways, and this would still ultimately be an azimuthal equidistant projection. So the people who think we live on a model, what happens if we change the projection point? Is this still the Earth? You see the problem? So, how to prove the convergence of meridians that do not exist on Earth? Well, first, do the latitude lines and the latitude circles displayed on the Gleason's map accurately display distances? Is the outer tropic larger than the inner tropic on this projection? No. No, the AE projection actually depicts both tropics to be the same length because it is projecting that spherical coordinate system known as long lat. As we always go over, the visual distance scaling of this projection is tied to the latitude-longitude coordinate system, not the visual distance scaling of a visible line. This is pivotal to understand. So, how would you measure latitude lines on the Gleason's map? Well, the same way the globe does. Calculate angles based on angles to the stars. What Jeran did in his flat Earth distance between southern meridians math test on his stream was absurd. Let's go through that real quick. I am sure that a glober presented this flawed method to him, and he misunderstood this as a valid way to measure longitude convergence on that AE model, right? Which again, if you were to do this, would be completely misusing that tool, and I'll explain exactly why. The method that I saw Jeran do was a basic circumference formula calculated from the distance from wherever you want to measure to the North Pole. I can see how it would seem like a good idea, but this does not work with the purported distances of the Earth, right? If you would take the distance to any point to the North Pole and call that r, and then calculate 2 pi r to get the circumference of that circle, you're missing a big point of this map, right? So this is exactly what Jeran did. He would take a point, you would draw the distance to the North Pole, you would call that r as a radius, and then calculate 2 pi r to get the circumference of that circle. he would take that result, divide it by 360 degrees to get how many miles per degree at that latitude, okay? What he's really doing is calculating latitude circles, and then dividing it by 360 to get miles per degree, right? So again, for comparison, 69 miles per degree is related to the equatorial globe circumference, which is linked to sun angle measurements, not to the Earth, right? So that circumference could be called the sun arc, right? The arc of the sun can be corroborated to be measured at, 24,901 statute miles. But he's doing it at the outer southern extremities and then trying to get the actual distance of that circle on the Gleason's map. Now, that's absolutely not how you would use the Gleason's map. What you're doing is not geometrically sound, and I'll explain it. So we already went over that as a property of azimuthal equidistant projections, it also preserves directions. It's a direction preserving map from the center. So the meridians from the globe are actually stretched out on this flat map, and they represent the same distance. For example, the line from the North Pole to the equator on the globe, 6,218 statute miles, because you use 69 miles per degree to get that quarter circumference, and that is a curved geodesic. So that is a curved distance of 6,218. However, on the Gleason's map, in a linear fashion, it is the exact same distance splayed out. This is, in fact, an aspect of the azimuthal equidistant projection. It straightens out great circles, right? It corrects great meridians, meaning this same geodesic curve distance can be displayed as a straight line. It's an aspect of this map. So to not understand that and then try to get a circumference of that circle, not taking this into account, gets you some weird dimensions, which again is not indicative of the real Earth. In particular, the meridian that he is using is one of these straightened out great circles. This is why this method is mathematically retarded. It is using what is in fact already a straightened out great circle as a radius for another circle. I'm not sure if everyone's aware, but a radius has to be a straight line, has to be linear. It can't be a curved line or a geodesic, which is what that line is on the orthographic globe, right? So another flaw in the absurd method of calculating meridian convergence is you're trying to use a circle from a geodesic, which is not a straight line. So the only way to measure actual longitude convergence on the Earth would be to measure the ground with which it's purported to converge with verification to the sky. Since celestial symmetry applies in the sky to the south, it doesn't apply on the ground, right? The ground in the south is much bigger, much more spread out. This is not the same for the sky. And since they're measuring things based on longitude lines in the sky and latitude lines in the sky, the distance is symmetrical in the sky only, right? So since meridians do not exist on the Earth, it is actually hard to measure them. It's a hard concept that only applies to a spherical coordinate system to actually measure that in reality. And we know the relationship between the spherical coordinate system based on angles to the stars, the graticule, and the Earth. We know that it's based on angles to the stars and not the Earth, but most globers cannot differentiate the graticule from the Earth. And I think Jeran has always been in this group. In any case, if one were to think that they lived on the AE map with a circling sun, I can see how after a trip down south, one might return to the globe. Because let's face it, if you think you lived on a flattened out graticule, you never actually left the globe in the first place.
There you go. That's my whole thing.
Nice. These are really well done, man.
Thank you, sir. I've been putting them out one at a time to try and address like each point and then, wait because people aren't going to watch them all at once. But I was also trying to make them for this one debut so we could go through them all together all at once.
Yeah, I love all these visuals.
Also, this is I happen to use just one map. This is the height map. So like literally the elevation map of the world. Notice how the highest elevation is just the outer ring always, right? It's weird how that works.
I've stared at that map way too long. Building it on Fortnite on the Unreal Engine 5, I built the flat Earth map.
Nice.
Like to scale.
And recreated the Gleasons.
And it's crazy because there's all kinds of, younger people that were playing it with us when we were playing it. And I'd be like, okay, everybody, let's go meet up in North America. And they're like, where's that? It's like,
Never met her.
seriously? Seriously? You can't like pull up your map and it shows you the whole map and everything. It's like, you don't know what North America looks like. It's just the outline of all the continents and everything. Yeah, I don't know, man. Education system. I'm
Could
telling
be
you.
anything.
But no, those were great, man.
Oh wait, I think I still have
There was one more, wasn't there?
Kyle's. Yeah, Kyle left, but I have Kyle's video.
Nice.
Just-
Show that real quick, and then I'll do a Theo update because it's actually related to positions of the celestial bodies and refraction and the visual and spatial fields. So we'll go over that real quick, and we can wrap up.
Nice.
And then Karen or Zach, did you guys have anything that you wanted to address specifically?
I'll do mine, I guess, real quick. There's no proof, no, I don't know what this place is. I don't know if water lies perfectly level everywhere across the plane. I'm not sure. The way, to me, water lies 90 degrees perpendicular to the electric field. That's how water lies. And that's how I see it. Now, is the electric field perfectly even everywhere? For some reason, I don't know why what's the name of the map? It starts off high in the north and then goes down.
Ferguson.
Yeah, the Ferguson map, and then bows out, kind of just like that thing I made when I bent water. All I'm saying is, until certain things are done, which I don't know if they'll ever be done in my lifetime. Brian Mullins, I thought, had a great test to do, force the line, he called it, where you get something that's actually perfectly level, 2 miles long, and go take it out in the water and lay it down. And you should be able to see the curve of the earth in that. Until something like that's done, like all over the earth, I'm not going to go and say that the earth is perfectly flat because I don't know that to be true. So just have an open mind about this kind of stuff. The name calling, the this and the that we see a lot going around and everything. I don't think anybody actually knows. And yeah, there's going to be people that profess to know. But maybe they just don't get it yet. Give them some time. It's just, we have already enough of an uphill battle, trying to share this truth with the world. We don't need to be fighting each other. So instead of having beliefs that are set in stone, let's have ideas and share them with each other, And maybe we don't get along and we don't have to talk to each other. That's fine. But we don't have to be enemies with people. I don't know. It's crazy. And if somebody says something about you and this and that, and they don't want to be your friend, then okay. It's going to happen. There's a lot of people out there. But yeah, let's just calm it down a little bit with all the, everybody's on their own journey and their own path. And I'll be the last person to tell you what this place is. I'm not going to tell you, I know that this is that or this is that. I'll tell you what I know that I've done and seen with my own eyes, something that you can go recreate yourself. But unless you actually know something, consider it an idea. You don't know it, so you can believe it or not, but you don't know it. So let's make those distinctions, and let's just act accordingly in how a functioning society should work. Because there's just way too much crazy division on like every topic. Pick a topic, and there's people that are ready to go to war over it right now. It's just, we don't need this in society. So let's set a precedent on how people should act and carry themselves out here. And that's all I wanted to say. I don't know what this place is. I think it's magical and fabulous and an awesome ride. But I'm never going to tell you something that I don't know to be true unless I do. And that's, yeah, my two cents on that matter.
Nice.
That was way too positive. I'm gonna need you to redo it with a bunch more animosity. And could you throw a couple curse words in there?
Yeah, I didn't like it because you didn't make everyone who disagrees with you have to capitulate to your ideas. That was my least favorite part of your proposal.
Where's your false dichotomy?
Yeah, could you use 3 more logical fallacies too? I wasn't quite ready.
Yeah, it's just, come on, let's just, don't want to sound like Rodney King, but can't we all just get along, right? You know? I mean, really, we don't have to like each other. It's a big place. We can be in, even the internet is a big place. We can exist without ever bumping into each other on this thing, unless you make it so,
Yep.
you know?
Yeah, Karen, did you have anything you wanted to, any globular evidence that you would like to address? Heard any good curvature jokes recently? Why did the chicken get a theodolite to cross the road?
Oh my god. Yeah. Well, the only thing I can say is that I just think it's funny that all of these proofs relate to the sky. It's important if we're talking about Earth. We're talking about flat Earth. Why doesn't anybody pay attention to all the direct measurements that we've done of Earth's surface, where curvature has not been measured, time and time again, repeatable, observable. And I've got, I share openly on the Google Drive that I have the FE Core documents, 120-page PDF document with 7 measurements over large bodies of water where no curvature was observed. And we saw things that should have been behind a geometric curve. If the Earth is a ball, it's like basic geometry. Balls have curves. We don't observe that on Earth. So I think it's just important to remember that. And, just learn to be okay with not knowing the answer to stuff. We may never know what the mechanics behind the sky are, or how it works, or why it does what it does. And that you should be okay with that. I've become okay with that. I'm okay if I don't ever know, but I just know that it's not what they told us, and all the other lies that they tell us that are kind of based on that initial lie also, are easily seen through once you see through the lie of the globe. So it's not for everybody. It's not for everybody. Maybe other people don't want to think about things that deeply. People don't want to have to, dig beyond the surface of things, and they're happy doing that. And they can do that. People are free to live their life that way. It's why I don't really like arguing with people anymore. I'm just like, okay, well, you just want to believe that? Okay, go ahead. But there's plenty of other people who do care about truth and who are part of the discussion, and and who do want to explore these different ideas about where it is that we live. So
Yeah.
Thanks, Bob.
Thanks, Bob.
Thanks, Bob.
Yeah, I almost drove myself mad trying to figure out what the sun was. Like, for 8 months, I tracked it every day, took measurements with the sextant, with my camera, all kinds of stuff. And I erased like 100 YouTube videos that I had about the sun and all the sunspots and everything one day. I just literally almost went mad. It was just like, I was like, I'm done. I'm just done with all this. Forget it. And then you calm down and take a breath and wish you didn't erase all those videos, and now they're just gone and you can't get them back because I did them all on a phone and had to erase them when I was done making them. So
But you still have the wisdom
learn.
though from those observations,
Exactly.
And I did a lot of that stuff too. Early on, that's what I first got into was sun tracking and all that stuff with Dr. Zack, and
we were doing all kinds of sun tracking
all
with
that
people all
geeky
around the
stuff.
plane.
And I started using AutoCAD. I started modeling the globe model to scale in AutoCAD, and I debunked people saying that the Selenileon eclipse proves is a flat Earth proof, because actually it's not. And I learned that the hard way by modeling stuff out. But, it's funny because one thing about that is how, and I would go around for years, I was telling everybody, I'm like, you guys should stop saying that, because if one Globie picks up AutoCAD and starts modeling that out, they're going to debunk you and they're going to make you look silly. But it never happened. Why would it never happen? Because Earth has no curvature. And when you start messing around in AutoCAD and you start measuring the Earth's surface and comparing it to reality, you see that it doesn't make sense. That's why no Globie has ever picked up AutoCAD and debunked any flat earther with the selenial on eclipse, which you could easily do because I made the syzygy work to scale in a 3D program with no refraction, which is the other weird thing. They tell you that it works because there is refraction, but then I made it work with no refraction. So that's weird. But, there's just a lot to be learned from that. And that just to me is like another thing that reminds me that Earth isn't a ball. It just
Mhm.
isn't.
Yeah, it's definitely not what they're telling us.
It's not what they're telling us.
I know that. Yeah, that's something I know. I've done measured multiple times in every way I could think of, and yeah, we're not moving. Thanks, Bob. By the
Mhm.
way,
That was another thing. I rewatched the video, an old GLOBEBUSTERS stream where Bob was on it. It was talking about how the sun could work on a flat Earth, and they were talking about the Michelson-Morley experiments and Airy's failure and stuff like that. And it was just really good to hear Bob say, he was like, unequivocally, the results that we got could not happen on a globe. It just doesn't make sense. So he knew there was something mysterious going on in the relationship between the Earth and the sky, and it didn't deter him either. So it
I
shouldn't
wish I
deter us.
remembered my memories more because I ask him all the time to come down and tell me what's going on in the sky, and he may have, and I just keep forgetting. Yeah. No, there's been a couple memory or dreams where Bob's came to visit. They're pretty cool. It's yeah. I think he's doing all right. I really do. I think he's in a good spot and he's taking control of his universe. Like, yeah.
Awesome.
Hanging out with Rob Skiba
Mm-hmm.
and Zulu One and
Like
Mike Helmick and all
he
the
came
other
to
people that we
visit
love.
me in my dream. He's like, I want to go run through the snow. Watch this. And goes, bloop. And all of a sudden we're in a big field standing in snow. I was like, dude, he's getting it, he's mastering this domain already. Yeah.
All right, real quick before we get out of here, I wanted to give a quick celestial theodolite update.
Nice.
All right, so we will be going over this on Monday. So on the Space Audits YouTube channel. So if you're not subbed over there, check that out. We'll be going over this
Crazy.
on Monday at 8 p.m. on the Earth Awakenings Discord server. But this is the basic premise for it, right? So we have an observer some distance away from a mountain. He does plane trigonometry to calculate what the raw elevation angle of that mountain would be if the Earth were flat. And then you do the same calculation, just subtract 8 inches per mile squared essentially from it to get the missing elevation for what the elevation would be if the Earth was a globe with respect to this position. And then what you do is you go into Stellarium, you go to the peak of this mountain, and you look up the angle for the flat, whatever you calculated for the flat Earth position. And when a star intersects with that angle, you write it down. You write down the date and time, and then you wait until that date and time comes by. You make your observation, and if that star is no longer visible at that specific time that corresponds to that angle that you calculated, then that shows that the physical elevation of that mountain peak is what you calculated it rather than being lower than what the globe would predict, because the occlusion timings are mutually exclusive. They correspond to a specific elevation. In fact, going over this formula here from Mike, who started the celestial theodolite observations, and if you haven't seen that GLOBEBUSTERS episode where Mike came on and broke it all down, you should check that out. I think that was episode 3 or 4. But this calculation here is extremely important because what he had noticed when he started going over these observations is as the angles get lower in the sky, they start to overlap with what appears to be, it's like, oh, well, this could work out on the globe. This could be the globe prediction here. Well, when we actually calculate the timing of occlusion, we can get what the actual elevation of the mountain is here. So the new calculation, or for comparison, is to get the altitude of the peak, the true altitude of the peak. You take the altitude of the observer plus the distance to the peak times the tangent of the true elevation angle of which it was occluded. So when we go back to that, let's see. when we go back to that original reference here, and we were on Stellarium and we were looking at what angle, okay, when we take that same angle, when it gets occluded, we could convert that into what it would be in meters for the altitude. So then we could compare what Google or whatever they say the official altitude of these peaks are on the globe. When you go to the Wikipedia and you look at the elevations and the stats and all of that is with respect to what they're telling you it is on the globe. And then we have the actual measurement converted through the angle and distance and altitude there. And we have the difference plotted out over here. And we have on the right of that, we have what the globe predicts the difference in elevation is. And then here we have the total difference from the globe and flat earth predictions. And as you can see here, none of these match what the globe predicts the actual elevation is. And using star occlusion timings, we're predicting that it's matching the flat earth calculations and it's nowhere even close to the globe. So in other words, this mountain relative to this observer over here on the right is never tilted away from the observer because of globe slant. It's never lower because of globe slant. These are all optical, right? If you were to get a theodolite out and measure the angle between this observer and this mountain, it would be like 219. It would be significantly lower. But the timing in which the star disappears corresponds to a real geometric position that this star or that this mountain has to be higher to actually occlude it. So that is the significance of what's being put forward there. And we're going to go over this again on Monday. So stay tuned for those updates. But yeah, in regards to refraction, trying to find curvature, I think one of the most important things you could do when comparing Earth's surface and when trying to measure is it flat or is it globe is you have to have an external reference, right? And now the globe is built on using the stars as, which is the only external reference that we have things in the sky, right? Because everything else is attached to the ground. But here we have an instance where using planar trigonometry, we're showing mutually exclusive timings that correspond to planar geometry in the spatial field rather than the visual field. Now, the visual field, all that stuff about we see in a sphere, the sun arcing across us relative to our latitude and all of that. These are how we distinguish the visual field from the spatial field. And the spatial field is coming up Euclidean, which means the Earth is planar.
Right. In reality, everything is planar, but our perspective puts it in a sphere around us, right? So that's all perspective induced, meaning the optic precession is optics based. It's not truly there. So if you do actual occult timing, right, and where is its true position comes up flat every time. So
Yeah, that's just a genius test. That's
well, the dude
It is
came up.
because I like that it's a sky observation that matches flat Earth and debunks the globe.
Dude, to an insane degree.
So much so that that's how he convinced himself. Right, he came up with the proof and then used it on himself.
Dude, and the other
That's
cool
amazing.
part about that is that conversion he was doing to get what the actual elevation would be. He solved a problem that we hadn't even encountered yet until we were arguing with the Globers, and then they were like, "Hey, some of these angles, are ambiguous to say the least." And I started looking into it, and I was like, "All right, fair enough." And then I asked Mike about it, and he was like, "Yeah, so this is what I'm doing to calculate what the elevation actually is now." And it's not even close to what the globe predicts. So
yeah, they would take advantage of a small angle approximation where it got really minusculely small. They could squeeze the globe right in there.
They could squeeze the globe.
So Mike came along, just got to straighten that out real quick.
Snatch the globe right out of him. All right, guys, what do you guys got coming up this week, Karen?
Just Monday coffee talk. I'm still pretty busy with puppies and stuff, and
yeah, it's springtime
and working in the
Nice.
background. So I'm only doing that for now, and I still don't know anything about doing any new scripture study streams. So that's it for me for now. And
Awesome.
GLOBEBUSTERS Tech on Thursdays.
GB Tech. Shout out to GB Tech and Coffee Talk on Mondays. Zach, what do you got coming up, sir? Let me guess. Iron Realm Media, Wednesday, Thursday, Friday?
Monday, Wednesday, Thursday.
Monday. I was close. Nice.
Almost. Yeah. Every other day. Monday, Wednesday, Friday, and then of course Thursday night GLOBEBUSTERS Tech. And maybe a Have No Sphere. I know Carol with the K. She's helped out at a lot of the Flat Earth festivals and stuff like that. She'll have a booth. She's wanting to do something out in Arizona this winter, maybe in Quartzsite, Arizona. and we were going to have her on, but we were having trouble getting a hold of her. So I don't know if that's going to happen Friday or not. We'll see.
Inshallah, she makes it, brother.
Yeah.
Shane, what do you got coming up, sir?
I don't know. Whatever you got coming up for Tuesday. Are you doing an ether prez? Someone's doing a prez on Tuesday, and then.
All right. So there was this Russian lad who took an interferometer and used tubes with different mediums in them to measure the differential in the speed of light using the fringe patterns produced by those as they interact with the two different mediums. So we're going to be going over that as it largely relates to Fresnel's original ether hypothesis about how light propagation will be affected by the density of ether in a material medium.
Super exciting.
Yeah, it's going to be awesome. All right. Well, that rounds out episode 14 of season 13. See you guys next week.
Later, y'all.
Peace.
Oh, I almost forgot to read the super chats. 1 second. All right. We have Liz the Iron Maiden says, "Rest in peace, Bob," with a candle emoji. Peace
Love
be
you,
upon
Liz.
him. We have JT who wants us to play an Instagram link. JT 11-month resub. Can you guys preview this link? It's short and high quality, in my opinion. If not, check it out later. All right, JT. Because you are the president of Flat Earth, I will acknowledge your request.
Is that a direct order? Okay. All right.
Our commander-in-chief wants us
That's
to play an
Run
Instagram
Boston
video.
Bear, for those of you in chat that don't know. JT. Yeah, Run Boston Bear. He's president of Flat Earth, in my opinion. He's just a great guy, dude. He's got such an amazing heart. Like, if I could pick a president, he would be
Share
somebody
audio.
I'd want up there, in power.
All right.
Yeah, that's why we rigged the election to make it so, man.
Yeah, that's why we tell everyone they can vote, but we make sure that there's only one candidate that wins. All right, here we go. Let me know if you guys can hear this.
So the Earth is spinning every day, but it's also going around the sun.
How do I make this not tiny?
It says you muted yourself too.
I give up. All right. See you guys next Sunday. Peace.